All right. So today for Fridays, since we didn't have class the second half of the week, we're gonna do some review. So this is gonna be anything from the first 2 weeks of the unit and a little more extra practice. So in a fun-sized pack of Skittles, there are 2 green Skittles, 4 red Skittles, 1 yellow Skittle, and 3 orange Skittles. So what I like to do when I'm given numbers, I like to make a little table. That's not straight. Okay. And I want to write in what I know. And what would be helpful to them. So I do know that I have green, red, yellow, and orange Skittles. What did we mention that was also nice to have? Total. This would help us whenever we're comparing a Skittle color to a total or a proportion. So you'll see that for parts B and C. So question A is telling us, well, first let's fill this out. We have 2 green, 4 red, 1 yellow, and 3 orange. That gives us a total of 2 plus 4 is 6, plus 1 is 7, plus 3 is 10. So we have 10 total. What's the green to yellow ratio? Well, green, yellow, we have 2 to 1. And we could write that also as 2 to 1 or 2 to 1. Remember, if it's asking us for green to yellow, we want to keep it in that order. If it's asking us for yellow to green, it would be opposite order. It would be 1 to 2. So remember that. And then we can move on to part B. What percent of Skittles are red? Well, we're being asked about red, so we care about the number 4. What other number or what other numbers and category is important? If we want to know the percent of the fun size pack that is red, it is the total. So whenever we want to find a percent, we are finding a piece of a whole. So 4 out of the total is our piece of the whole or a proportion that we want to make. Actually, this is a ratio that we want to make, 4 to 10. But this still doesn't answer what percent. Percent has a percent sign and it's per 100. So I can make this per 100. 10 to 100, I could just cross multiply to find what this top number would be. Our percent. So if I cross multiply, I get 400 equals 10p. Divide by 10, I get p equals 40. So that's 40%. Okay. So next, I am being asked if I buy a big bag of 120 Skittles. Okay, that's the total Skittles. It doesn't tell me if they're red, so I'm assuming that's the total Skittles in the big bag. And the ratios are the same. Okay, cool. So I could use my number ratios up here. How many yellow Skittles would you expect to have? Okay, well, what I can do is make proportions. I could do something I'm given and I know equals something I expect. So if I know that for every 10 Skittles, remember that's total, sorry, excuse me, that's total. I have 1 yellow. How many would I expect? How many yellow would I expect for 120? Remember, these two should align and these two should align. So these are, this one on the bottom is total for fun size. This is total for big bag. So they should align. I'm going to erase that. Now, all I simply have to do is cross multiply. Oh, that was a 10. And I have 10y, that's this times this, equals 1 times 120 is 120. And then I divide, because remember, opposite operation. If I'm being multiplied 10 times y here, I want to divide by 10. And I do that on both sides. Have y equals 12. I expect to have 12 yellow Skittles in a big bag of 120. All right, next, I have some interesting stuff I have to solve for. So whenever I see things like this, I need to right away, it helps me to write PEMDAS. Parentheses, exponent, multiplication, division, addition, subtraction. Okay. So do I have any parentheses? The answer is yes. I actually have two sets. Brackets are parentheses as well. Usually the order is that first you'll want to do parentheses, then brackets. So here I have 4 plus 2 is 6, and then that's around some brackets. I still have this minus 2. I still have this minus 1. I still have to divide by 2. I still have more parentheses, so I'm not going to move on to E. 6 minus 2 is 4. And then I'm bringing everything else down. That's where these numbers came from. Do I have any exponents? Well, no, there's nothing as an exponent. Do I have multiplication? Yes, multiplication and division come next together. There is no addition and subtraction. This is a negative one. It's not minus 1. So I could go ahead and multiply these two together first. It's negative 4 divided by 2. That gives me negative 2. If I were to do these two together first, it gives me the same answer. I have negative 1. If I do 4 divided by 2 is 2. Answer is the same because multiplication and division can happen at the same time. There's not a priority. Same with addition and subtraction. If they're together, there isn't a priority. Okay. Regardless, the answer is negative 2. Next, we're being asked, what is the simplest form of the product? Product tells me multiplication. But what am I multiplying? Well, I'm multiplying 7 and this, x increased by 2. So here I have one number, here I have a variable and a number. Because it's x increased by 2, it's x plus 2. This addition sign or any sign that I have, I'll want to put all this in parentheses. This, it's its own term, x increased by 2. If I'm finding a product of two things, I could just put the 7 right behind it or put the multiplication sign. It really doesn't matter. Parentheses signify multiplication, so I could leave it like this. And I don't really mean simplest form. I just want you to distribute. So go ahead and practice that. What do we get? You should get 7 times x, 7x. 7 times positive 2 is 14. This is what we want. Next, we have what is 3 times 7 plus x. This could have been asked the same way as number 3. What is the product of 3 and 7 increased by x? So if you needed to hear that, that's what it would sound like. So again, distribution. Is just the little arrows, the little rainbow, if you want to think about that. It is 3 times 7 is 21. 3 times x is 3x. That's my distributed form. All right. Next, if Janice goes to the store and grabs a pre-packed bag of X amount of apples and then adds 2 apples to 3 bags, what expression would help us determine the total number of apples? Okay, so we have 3 things. We have X amount of apples, we have adding 2 apples, and we have 3 bags. So I know that each bag has X amount of apples, and Janice adds 2. So I have X, 2, 3. I already took care of the X. I already took care of the 2. It's adding because it says she adds 2 apples. But how do we know this operation comes first? Well, this tells you how much one bag of apples would have when she adds 2. If she does this to 3 bags, all we have to do is 3 times the amount of apples in the bag that she configured. So if she does this 3 times, again, we know, even just saying that she does that 3 times, we know that that needs to be multiplied. And that's what this does. Putting a 3 outside of a parentheses tells us that she's doing it 3 times. Does it 3 times. So our expression is simply 3x plus 2. Next, if she then goes and counts the total number of apples to be 21, how many apples were originally in the bag? X is given the pre-packed, so this is original. It's defined here as well. So we found out that this expression equals 21. So now it's an equation, right? There's an equal sign. If you remember from our Wednesday, Thursday session, whenever we see parentheses in an equation and we're being asked to solve for x, we want to distribute. So our first step is distribute. Our second step is, if we have like terms, yes, we want to combine them, but that really doesn't matter. We could combine them at the end. But what we really do want is to have variables and numbers on opposite sides of the equal sign. So, okay, I'm gonna go ahead and distribute. So if you distribute, what do you get? When I distribute, I get 3x plus 6 equals 21. That's my first step. Then I want to make sure that all variables are one side and then numbers are on the other. I typically always leave variables to the left. It really doesn't matter. I could make them to the right and move all numbers to the left. But for this purpose, I'm going to go ahead and get rid of the 6 and put it over here and leave that 3x on its own. So if I want to get rid of the 6 or do opposite, I have to do the opposite operation. What is it? Subtracting by 6. This cancels, and then I do that to both sides. 15, have 3x, and then so that you can see it, I have 3x equals 15. And then what's basically my last step in order to solve for x, or the number of apples originally in the bag? It is to divide by 3 because it's multiplied 3 times x. And we want x by itself. I have x equals 15 divided by 3 is 5. There was originally 5 apples in the bag. So hopefully this helps you understand word problems a little bit better. This is the type of problems that you might see on the SAT, so it's good practice. If you need help with this, I recommend rewatching this. There's going to be the YouTube link linked in the Edpuzzle. But also make sure that you're pausing when you need to pause. So ask questions, okay? I'll see you again next time.